Okay, so we're still dealing with I today. I've been getting a couple of requests about different types of problems that have given us problems. So we're going to walk through a couple basic things that you'll be doing as far as operations involving I. First up, straight up multiplication. Now, if you remember, your teacher may have referred to this as foiling or distribution, but essentially for number one, we're just going to make sure that the 3i gets multiplied by the entire binomial and a -1 gets multiplied by the entire binomial. So let's do that rotation. We end up getting a 15i squared plus 6i, and then I distribute the -1 to both. Minus 5i minus 2. Now, I'm going to combine my i's right away. Now, keep in mind, I can combine these i's, but not that one because it has a different exponent. They have to have the same variable, same exponent. So my i's give me a positive 1i. Now, you may be looking at this thinking, wait, why don't we put the squared term first? Because we can simplify something here. 15i squared. If you remember home row, I squared is -1. So this ends up being a -15, because 15 times -1 would be a -15, giving us -17. And that is our final answer for the first problem. That's simple binomial multiplication involving imaginary numbers. All right, next, division. Now, I want to notice the difference between 2 and 3. 2 is a monomial denominator and 3 is a binomial denominator. So there is a big difference. We're going to treat them differently, and here's how it works. Because I represents the square root of -1, mathematically we are never allowed a radical or a square root in the bottom of a denominator. So I need to get rid of it. Well, we learned that to undo a square root, you multiply it by itself. Now, I have no problem with the 5. The 5 is fine. I'm going to leave it there. It's only the I that I don't like. So I'm going to multiply top and bottom by I. Now, you'll notice I'm going to have this distribution, and I'll get a 4i minus 3i squared up top. And I'll get a 5i squared on the bottom. Simple multiplication, tops, bottoms. Now, again, I see those I squareds that I like to get rid of. It's a -1, so this really becomes 4i plus 3 over -5. Just so we understand how that happened. -3 times a -1. Remember, I squared representing -1. On the bottom, 5 times -1. Well, the only issue with this, math language does not like a negative on the bottom, so we bring it to the top. Now, keep in mind, there's multiple things up top. So when I bring the negative, it has to go to multiple things, making it -4i minus 3 all over 5. And that is my final answer for when I'm dividing by a monomial imaginary number. This is the one that most people struggle with, though. It is a binomial. Now, we use the formula from difference of perfect squares to help us eliminate our middle term in this. We're going to be multiplying by the conjugate. Now, when I multiply by the conjugate, this is what that means. It's the exact same expression, only I am negating one of my terms. So instead of 4 plus 2i, I am now going to multiply by 4 minus 2i. I'll work down so we don't run out of room. Now, here's the nice thing about a conjugate. I mentioned earlier, it follows the same formula of a difference of perfect squares. Well, difference of perfect squares says if you have an a squared minus b squared, that's the same thing as a minus b, a plus b. Well, notice what we have. We have an a plus b and a minus b. So I don't have to do the long drawn out multiplication. I can use the formula and go straight to a squared minus b squared. For that reason, my denominator is now going to be 16 minus 4i squared. I didn't multiply it out because I know the cheat. Top doesn't have any of that, though. I can't cheat. I'm going to have to multiply it out. Very, very similar to number 1. 3 times 4 gives me the 12. 3 times -2 gives me -6i. -i times 4 gives me the -4i. And -i times -2i is a positive 2i squared. A lot going on here. Couple things. First off, I know I can combine my i's. So that gives me -10i. I see I squareds again. If I squared represents -1, then instead of 2 times I squared, it's really negative 2. Same can be said here on the bottom. Negative 4 with a negative 1 really represents a plus 4. And that is how we get a positive 10 up top and a 20 on the bottom. Excellent. You used all your new skills from Algebra 2, but don't sleep on that one skill from, what, 7th grade? Canceling fractions. They all share something. Now, if this was a 3, if that term there was a 3, I couldn't do anything. You can only cancel when they all share something. So, let's cancel them all. Leaving us with negative 1 plus 1i plus 1 all over 2. Make that I a little better. And that is my final answer for number 3. Multiplying by the conjugate, take your time, you'll be able to get it. All right, last one, solving. I actually think this is the easiest one. You'll learn a little bit. We're going to look to see if things factor first, but as of right now, we're just going to go straight into solving. Isolate it as if it's a pre-algebra problem. Let's get the variable all alone. Subtract the 16. Get a 2x squared equals negative 16. Divide by 2. You get an x squared equals negative 8. Now, at this step, we look at the problem, and in Algebra 1, we would have said no real solution. And that's actually correct. There is not going to be any real solution. Now, that is because we're dealing with complex numbers. I still go about my process, square root. So right away, x equals plus or minus. We have to represent the positive and the negative outcome here of this square root, which will help us when we start finding our actual roots on a graph. I see a negative, immediately I know I'm going to have I in this. And then I just break down square root of 8. 4 and 2, 2 and 2. I have a pair of 2's, so 2's coming on the outside. I had a negative inside, so I has to come out. Only thing left at the end of my roots is a 2. And that is how I would solve a binomial quadratic if I end up with imaginary numbers. Hopefully this helps. There's 4 types of problems you might run into on homework, reviews, or tests. Keep letting me know what problems you need to see more of, and we'll put more up. All right.